Okay, welcome back. We're on Lesson 6. We're going to talk a little bit about static methods and static properties. When you would use them and when you want to avoid using them, and when they're helpful to have. Okay, so let's go ahead and create a class. And let's just call it, let's just call it test. We can think of this as maybe a test that you take at school, some sort of written test or whatever. And let's create some properties here. And let's just say we'll have a grade, and we want to have a graded by. Okay. Alright, so far we're going to have that right there. We're just going to keep this real simple just because we're going to demonstrate, why would you use a static, and places where you would use a static, and where you wouldn't. So let's just talk about static variables, and then we can talk about static methods. Okay, so the deal with a static is that every instance of the class that's created, so every object that gets created, will carry that static variable. And if one class changes it, then another class will be able to change it. Or sorry, if one class changes it, then it will be in effect propagated through all of the classes that are currently existing. All the current objects that currently exist. So let's go over here and show an example of that. Let's create two tests. We'll give one test called A. This is going to be the A students test. And whoops, can't type today. And let's create another test called the B students test. So we've got two different tests out there. One is for the A student, the other is for this other student. So these should be completely different objects, and they are right now. These are two completely separate objects. Let's give the A student a grade of 50. They didn't do very well. And the B student, we're going to give them a grade of 70. They did a little bit better. And then let's go ahead and write out both of their grades. So we're going to write out the A student's grade. And let's go ahead and do the same thing with the B student's grade. Okay. So as you'd probably expect, A student is going to print out 50. This B student will be 70. So we should see a 50-70. And this is just to show that these variables are indeed going to maintain their difference. Run this. As we can see down here, 50 and 70. So these two objects that we created, this A student and B student test, are completely separate. There's no binding these two together, which is a good thing. I mean, you don't want, when this guy changes his grade, you don't want it to affect this guy's grade. So let's come back over here. Let's stop the program and let's see what happens if we make one of these static. In fact, we're not even using this one, so let's get rid of that. Let's create this as a static variable, okay? Let's come over here. And it's actually not letting us access this because we have created a static variable. And so it's actually letting us, it's notifying us that this is not going to work anyway, because the object, it's no longer part of the object, now it's part of the class. So instead of giving grades to each of the classes, if we create a test, we no longer have access to that. The only thing we have access to is one single grade. So we can change the grade like this, but each of these students no longer have individual grades because we made this a static variable. Okay, so if we put another one in here. Oops. And if we make this one an instance variable versus a static variable, we have access to that. Students. Let's see, so the only variable that we have access to is graded by variable. But we no longer have access to this grade variable because it's now just become part of the test class. It no longer becomes part of one of the objects that gets created out of it. And so it's a great way for basically making something that can be carried over. One situation that you might want to use this in would be if you had, for example, this form class. If you wanted to create some sort of variable up here, let's just create one. Public static integer counter. Some sort of count variable or whatever. And if you wanted to be able to access that easily from another form, let's go ahead and create another form real quick. So I just passed it. Okay, so form 2, that's fine. If I wanted to be able to access this variable from the second form, I pop open the code there. Unless I have access to that individual object that created form 1, I don't have access to this. Unless I make it static variable, and then I can access that by just calling the form2 class. And now I should have access today. Whoops, I called it, sorry, form 1. Confused there for a second why it wasn't showing up. Okay, so we can do some manipulations on this counter, but since it's a class variable, whatever, if I made multiple form 1s, then every single one of them would share this variable. I could not have multiple different counters. It would end up just having this one counter, which in cases of forms, that's generally just fine because you're only going to have one of those main forms. If you end up having a couple of them and you need to have them as different variables, you're going to have to make them instance variables and not static variables. If you need to pass them in to this object, it's generally done in the constructor, which is this piece right here that we explained in lesson 1. And the way that you would do that would be over here. Let's just say we're going to create a form2 object. So all these objects, you might be seeing them in a different context, but all of these are just objects and classes, going all the way back to lesson 1. We're creating an object right here. That's where this new is. That's creating an object. We're running the constructor. That's what those parentheses are. So this is the constructor when it creates the object. This coincides with basically this method right here. Remember how the constructor always has the same name as the class. So what we would do is we would expect to pass in something. Let's just pass the whole form in. We might not end up using it, but let's just pass the whole thing in. And basically this constructor happens, and the reason why you would want to pass it in here and save it away to a public variable that can be accessed is because, remember, the scope of this variable is just this block of code, which when the object gets created, this runs, and then all the variables that exist are gone after that. So in order to save it away, we need to save it away in something up at this level so that all of the methods below, like we might have some method down here that we might have some method down here that calls on, that needs to have that form 1, some variable from form 1. So we're going to just create a form 1, say this F1. Remember that you can refer to the current object by using the this keyword, and this is talking about the current. This class will create that current object, and then we're going to take whatever's passed in here, a reference to that form1, and we're going to set it equal to this form, so that basically this variable here and this variable here, in fact we can just call it different just so this won't be too confusing. It's like the original form right there. So this form, this variable here and this variable here, they're both form variables. They both refer back to that same form1. And if we want to get at a variable such as, let's make another one, another counter. If we want to access a variable like so, we're going to be basically passing this in. So we're going to pass in this, which this refers to as, if we hover over it, it shows us what it is. It's a form1 object. So this is the current object that is running this method. So this current object that's created from this class is being passed into this constructor, which is basically a method that is just, the only difference between constructor and a method is a constructor gets called when the class first gets created, and that's it. When the object first gets created, and that's it. So we pass a reference of this, which is form1, that object, into this form2 object that we're creating. And we're basically linking it up so that we have access to all the variables in there. So if we wanted to do something like this, we would have access to that form1 another counter right there. So we have access to that variable. In fact, we have access to all the public variables that are created. Back here in form1, we have access to all of them. If we created a private variable, not seeing whatever, we're going to see that we won't be able to see this one over here. Even though we have access to that entire object of form1, we don't have access to its private members. It should show up right below name right here. That's because it is a private variable. So that's public-private. So that would be a case where you might want to have a static variable. So instead of having to pass this in, if you're only just going to have one form, you're not going to be creating multiple, and you're not going to need to have it as different. You're not going to need to have different instances of this right here. You can go ahead and create it as a static counter, and then you can simply, instead of having to pass all that stuff through to the form constructor, you can basically just call it form1, and it's a static, and you have access to it right there. So and there you go. So that's basically the counter right there.